In this lesson, we'll go through the process to set up our tool library. After completing this lesson, you'll be able to import a tool library, modify tool parameters, and use form mill. In Fusion 360, we want to carry on with our spline coupler. If you had any issues, you can upload the supplied dataset, spline coupler dovetail. That dataset won't include the UMC 750 table, but it will have all the information you need to follow this lesson and create a dovetail cutter. We're going to start by expanding our bodies folder, showing our stock, and hiding our part. We want to create a new sketch, and this is going to be on the YZ plane. And we're going to use Create, Project Include, and Intersect. For our selection, we're going to use Selected Entities, and we want to select the faces of interest. In this case, it's going to be this taper and this short section here. We'll say OK and navigate back to a right-hand view. Using our line tool, we'll begin designing our cutter. We're going to come out to the left, come up, we're going to come over to this point, and then we'll use our constraints to make sure that this edge is vertical. Using our sketch dimension tool, we'll start by selecting the axis of revolution, and then the end point that'll be inside of that dovetail. We'll right-click and turn this into a diameter dimension. We're going to make this a 1/2 inch diameter tool, and we're going to give it an overall length of 2 inches. Once we've got this profile, we can finish the sketch. We want to expand our sketches folder, and we're going to rename sketch 8 to be our dovetail. I also want to note that inside of your user preferences, you want to make sure that you have cloud libraries enabled. This will be in the general manufacturer section, and you can enable cloud libraries here. Now we're going to navigate to the manufacturer workspace. And we want to begin by going into our tool library. If there are any tools in the current document, inside of here, you notice that there are some tools. We can right-click and we can remove unused tools. This will clear out any tools that were saved in the design. Now, in the case of using distributed design, if you brought in additional functionality, such as a fixture or a table, that were part of another design, they might contain data. So this is why it's always important that you check some of these before you get to programming to make sure that you don't have extra tools in here that don't match the specific library. Now, in the cloud section, I'm going to right-click and I'm going to import. I want to navigate to the location of my multi-axis tools and select Open. Now we've brought in 11 tools, including spot drill and drill bits, taps, flat end mills, ball end mills, a taper mill, as well as a chamfer mill. The one thing we're missing is a dovetail cutter. And we're going to do this by going to Manage and selecting Form Mill. We'll begin by noting the coordinate system here. Z is pointing up. And when we select our profile and we select our tool axis, you'll notice that we get a red arrow on the screen. The red arrow on the screen is pointing up toward the machine. However, we need to flip our tool over. For the compensation point, I want to select the point on the outside edge of my dovetail. I'm going to say OK, and then I want to go into my tool library and check on that form mill. You'll notice here that the form mill is created upside down. It's created based on the coordinate system of our design and the orientation when we created it. Let's go ahead and try creating it one more time. We'll select form mill. We'll select our axis of revolution. And instead of flipping the axis, we're going to leave the arrow pointing up and we're going to say OK and check the tool library. So now we have 2 different form mills in 2 different orientations. This is going to be important because, again, it's referenced based on the Z up coordinate system. So if we have to flip it over, you'll just need to make sure that you use that flip option. I'm going to delete the upside down tool. And then for my form mill tool, I'm going to double click to edit. I'm going to start by going to the post processor and we'll make this tool number 12. Then you'll note in the cutting data section that all of the information is empty. In this course, we're not actually going to be using this to cut our geometry, but it's important to understand the process anytime you need to make a custom tool. So if we want to add specific information, for example, if this tool is going to be at 5,000 RPM, The ramp spindle speed will also be at 5,000 RPM. We'll just simply need to go down the line and enter all the data that we want to use for this cutter. I'm going to run it at 20 inches per minute and notice that it populates most of the other values. For my ramp, I'm going to run that a little bit slower. And then I have this data in here for plunge feed rates. I'm not going to be plunging with this tool, but it is still asking for this data. So I'm going to go ahead and enter it, and I'll allow flood coolant to be turned on anytime this tool is used. So again, we can double check all the information we have. We can enter data such as the number of flutes we have, the material, if it's specified, and then any additional information that we might want to change. For example, the diameter. At this time, it's 0.5 based on our sketch. If we try to increase this, notice that nothing changes in the preview. So in general, you want to make sure that you leave this data based on your sketch profile, but it does allow you to come in and make modifications. It's also important that we add a description. I'm simply going to call this a dovetail cutter, but in reality, you would necessarily have a vendor or a product ID, and if you're getting a custom tool made, then you would want to put that information in there as well. Now that we have our dovetail cutter, I'm going to right-click and copy the tool. Then I'm going to go to my multi-axis tools cloud library. I'm going to right-click and paste it there. So that way it's included in that library, even if I use it in another design. From here, I want to make sure that I select closed. I'm going to expand my models, and I'm going to hide that sketch because it's no longer needed. I also want to show my part as well as my table and all the fixturing that I created and go back to a home view. At this point, let's make sure that we save the design before moving on to the next step.